we talk about the finished. We finished confirmative factor analysis. And did we finish that part? Not yet.
What model?
Model fit. Model fit. So we talk about CFA, but didn't finish that part because we already talked about model fit. Okay.
What model did?
Do you mean only these indices model fit? We didn't talk about confirmatory factor analysis.
When then you show how to roll the structure for
Okay, the first have a point here. So now you know how to create the model. How to create the model. How to draw the model. You know how to do that. Okay. Okay, so now we interface. We change it to legal. Okay. Then we go to analysis. I told you about how to.
Yes.
Yeah.
Sure.
Okay, so now we create a model. Let me think. Which model? And you also know about the difference between latent variables and manifest variables, right? Yeah. Okay. So now, because manifest variables, this is a special type of equation, structural equation modeling. So now we merely use latent variables. Okay, so for example, now the data. Oh, no. I have to use the data. Oh, that's why. I have to use the data without missing values. Without missing values. Okay, so now we use ABCD.
Please show me the
As
data.
what?
Please show me the data. We don't have the data.
You don't have the data?
Last time.
I shared the data already? No?
No.
Sorry. Okay, I share the data with you. But how? How can I share the data? WeChat? They copy this one. But now you download the file.
Yes.
And yeah, you can transfer. Okay. So now I use the data. Okay, so now you can see the data in here. All the data is here. Okay, so now I want to create 5 latent variables, respectively representing A, B, C, D, E. So now we create the latent variable for A, and it has 6 indicators. 3, 4, 5, 6. And I create latent variables for B. It has 5 indicators. 5 indicators. And we create latent variables for C. It has 4 indicators. For D, it has 3. Oh, and for E, it has 5. It has 5. Okay. Did I tell you some specific rules you have to pay particular attention to when creating your own models? Did I? For example, you have to create residue for the predicted variable. I said that. Yes. Okay. Something that you have to pay special attention to. First, you have to create residue. You have to create residue for each predicted variable. For each predicted variable. Second, the names of the latent variables. The names of the latent variables cannot be the same. Cannot be the same as the ones in SPSS. Here, these are the names in SPSS. So if you name the latent variables, the names cannot be identical to the names in SPSS. For example, if I want to give the name to latent A, it cannot be A. If you give A to the latent variables, it will be the same as this one. You have to change the name. Yeah. So this is about name. And also pay attention for all those parallel predictors, mediators, and outcomes, you have to draw covariances among them. You have to draw covariances. Covariances among them. later I will show you what is covariances. What is covariance? Okay, for parallel predictors, for parallel mediators, for parallel outcomes, you have to draw covariances among them. And so yeah. You have to save. You have to save your model before you perform your analysis. Before you calculate, you have to save the file. You have to save the file before you calculate. Before you calculate. What is missed? Let me check. Okay. Okay, that's all. That's all. One last point. One last point. Pay attention. Can you see this? For each latent variable, for each latent structure, there is one. Can you see the one? Yeah. For each of them, there is one. You have to give. So these are what? These are the factor loadings for each indicator. Factor loadings for each indicator. But these factor loadings are unstandardized. So you just remember, for each factor loading, you have to one of them have to be one. One of them have to be one. So we often make such mistakes, especially when we delete some items. For example, sometimes I may have to delete this one, this indicator, this item. If you delete this one, see, this one will be gone. In that case, you cannot calculate. So if you really have to delete this indicator, you have to double tick another factor loading and set it as one. So one point is there must be one among these indicators. Here there is one, there is one, there is one, there is one, and there is one. Yeah. Okay. So the last point is about this is unstandardized. Unstandardized factor loading. Standardized factor loading. Okay. So now the 5 latent structures are already there. And I move them a little bit. Okay, so now I can put the data A1, A2, A3, A4, 5, 6. Okay, for B1, B3, B4, B5, for C, 1, 2, 3, 4. For D, 1, 2, 3. For E, 1, 2, 3, 4, 5. Okay, now all the data have been transferred in the model. For each latent, they are represented by their own items, indicators. Okay, is that clear? Yeah, okay, so now we do this one by one. We do this one by one. Okay, so residue, how to deal with this point? How to deal with this point? Residue, which of them is the predicted variable? E, right? Yeah, E is the predicted variable. So I add a residue for E. Okay. Okay, next one. Name these latent variables. So I double click text, so you can give them a name. Okay. Can I name it as A? No. If I name it as A, this name will be the same as the one in the SPSS. Yeah. So I can, for example, I can name it AA. And similarly, BB. CC. And DD. EE. Okay. Now we give them the names. Next one, for all the parallel predictors, mediators, and outcomes, we have to draw covariances. What does it mean? It means, can you tell me first, which of them are parallel predictors, mediators, or outcomes? Which of them are parallel predictors? We use A, B, C, D to predict E. Which of them are predictors? Which of them are predictors? A, B, C, D, right?
Yeah.
So you have to draw covariances between A, B, C, D. which means you have to draw correlations among them. Draw correlations among them. Did I tell you how to draw the correlation? How to draw the correlation? Here, right? Yeah. Okay, so you can do it one by one. Okay, then so now I have already drawn the covariances between each of them, right? Yeah. But you know what? When we have more predictors, if you draw them by hand, it's probable that you can make mistake because you have so many predictors. Yeah, so we don't draw them by hand. We have another option. Now I delete them. I can select the 4, and you go here. Here, plug in, you go here. You can see this one, draw covariances. If you use this one, you can see. If you use this one, you can see the software will automatically create covariances for them. So if you use this one, you won't make mistakes. Okay. Okay, we draw covariances between parallel predictors because E is the only outcome. So there is no need to draw covariance. Yeah. Okay. So next one. Okay, you have to save your file. You have to save your file. Okay, you save. Save you. If you don't save it, you cannot. You cannot calculate. Okay, here, then I auto save. Okay, I save. Now you can see there are many residue errors in here. So many residue errors in here, including this one. So you have to name them. You have to name them. And we normally use them here. You go to plugin. You can see this one, name unobserved variables. Name unobserved variables. You use this one, you can see. Now we name all of these errors. All of these errors. Okay. Then, because I use A, B, C, D to predict E, Okay, now this is how we create your hypothesized model. Now we can calculate. You see, this is for calculating. Now it's calculating. All the results almost all the results are listed in here. Okay, so now I can show you. For example, we know we have to name it. We have to give it a name which has to be different from the name in the SPSS. Suppose, for example, I don't name it as AA. Instead, I name it as A. If I name it as A, it will be the same as the name in the SPSS one, right? Yeah. Okay. Now let's calculate again. Can you see that? It's not a lot for calculating. Yeah. That's the reason. So it has to be different from the names in SPSS. Okay. Now calculate again. Okay, now you go to the results. We always been talking about model fit, right? Model fit. Now you can see this is for model fit. This is for model fit. You go to model fit. Now you can see the data. What indices are important? What indices are important? The ratio between chi-square and the degree of freedom, right? Yeah, you can see this. This is chi-square. This is chi-square. This is degree of freedom. The ratio is here. The ratio is here. Okay, so now is this indeed acceptable? Is this ratio acceptable? Is this acceptable? Is this acceptable? I've told you, right? The ratio has to be small, has to be below 3, right? But for this is a strict rule. We have another rule that is not strict, which is 5, right?
Yeah.
Which is 5. So if the ratio is below 5, it's acceptable.
Yes.
If it's below 3, it's good.
It's tricky.
Below 5, it's acceptable. Below 3, it's excellent. It's good. Okay, so now, is this ratio acceptable?
Yeah.
Yes, it's acceptable. It's acceptable. Next, CFI. CFI, strict. For strict rule, it has to be above 0.95. Yeah. In this case, it's excellent. But if this value is above 0.9, it's acceptable, right?
Yeah.
Okay. This is CFI. This is CFI. Is this acceptable? It's acceptable, right? Yeah, it's acceptable. Okay. TLI. It has to be above 0.9. This is TLI. This is TLI. This is TLI. Is this acceptable? TLI? No. It's below 0.9, right? Yeah, it's below 0.9. Okay. RMSEA. RMSEA, again, the strict rule, it has to be below 0.06. In this case, it's excellent. But if this value is below 0.08, it's acceptable. It's acceptable. So now you can go here. Can you see this is RMSEA? The value is 0.058. It's good. It's good. Because it's below 0.06. It's good. The last one, SRMR. SRMR. Pay attention. SRMR is the only one that is not reported in here. It's the only index that is not reported in here. Where can we find it? Where can we find SRMR? Go back. You have to tick here. So now you can see in here, in this plugin, we have three functions. The three functions are the ones we use often. The first one we use draw covariances. Just now we use this one, right? We use it to draw covariance between A, B, C, D. Okay. We use this one, name unobserved variables. Unobserved variables. If there are any variables that are not named, you can use this one. It can automatically name the variables in your models. For example, I remove DD, So you can see there is no name for this legend, right? There is no name. If you use this one, you can see it will automatically name as F1. Okay. We use this often. DD. Okay. Last one. In here, last one. Can you see this one? Standardized RMR. This is SRMR. standardized RMR. This is just SRMR. You have to tick this one, then you can see a blank in here. Then you calculate again. Then you calculate again. You see, the SRMR for this model is 0.06. 0.0627, 627. Okay. Is this acceptable? It has to be below 0.08. So it's acceptable. It's good. It's good. Okay, so now we can find these indices. Simply, it's very simple. You just go to findings, then you go to model fit. Then you can find all of these indices. Okay, now for this model, the model fit is the model fit indices are acceptable, right?
Yeah.
Generally acceptable. All of these indices meet the requirement. TLI is the only exception, right? TLI is the only exception because TLI is the only one that is below the criteria. The only one that is below the criteria. Okay. But it generally, it's generally acceptable. Okay, so now this is what? This is how we draw the model. How we draw the model. This is, so you have to know how to do that. But now I have to create the model into two types. We divide the model into two types. One is two models. One is measurement model. The other one is structural model. Structural model. Do you know what is measurement model? What is measurement model? Anyone? No? Did I say that? No, I didn't. Measurement model. You know about CFA. Know that? Yeah, in SPSS, we know how to conduct EFA, right? Yeah, that is factor analysis. And said that we have two types of factor analysis, which is EFA and CFA. Yeah, measurement model is CFA. Measurement model is CFA. It's CFA. Confirmative factor analysis. Confirmative factor analysis. What's the use of measurement model? What's the use of the measurement model? It's used to confirm your data quality. You have to confirm the quality of your data using the measurement model. Quality of your data. Next question. How does measurement model look like? How does measurement model look like? Measurement model, no prediction. In the measurement model, no prediction. No prediction. Only correlations. There is no prediction. There is no prediction in the measurement model. There are only correlations in the measurement. Now, please check this one. Is this measurement model? Is this measurement model? Why? Why not? Yeah, because there are predictions in this model, right? Because we already use ABCD to predict to predict E, right? So this is not measurement model. Okay. Now let's look at what is structural model. Structural model. In the structural model, there are predictions. There are predictions in the structure. How can you know whether there are predictions or not? How can you know that? There are predictions or there are not predictions. How can you know that? If you have these lines, there are predictions, right?
Yes.
Yeah. This is used for prediction. Yeah. So this indicates prediction because we use D to predict E. Yeah, we use this type of line. Yeah. So this is what. Just now, this is not measurement model. What? Right?
Yeah.
It's not measurement model. What model it is? It's a structural model. It's structural model. Okay, that's it. That. We talk about them one by one. Now we talk about measurement model. Measurement, CFA. Why we talk about measurement model first? Why do we have to talk about measurement model first? Because you have to confirm the quality of your data first. Then you can tell others your findings. Right? Yeah. So that others will believe, will think that your findings, your results are convincing. If you don't confirm your quality, the quality of your data, we don't believe your findings. Don't believe your findings. So this is why we conduct measurement model. We conduct confirmatory factor analysis first. first. Okay, so measurement model we talk about. So now we change this model to measurement model. This is structural model. We change it to measurement model. How does measurement model look like? How to change that? How to change that? I remove all of these arrows, right? Yeah. I also remove these covariances. What else? What else? I have to remove this residue, right? Have to remove this residue. Okay, the next, I select all of these selected. Then I draw covariances between them. I draw covariance between them. This is what? This is measurement model. This is measurement model. Okay. Now we count. Oh, again, we select SRMR first. SRMR first. Okay. Then we calculate. So okay, now this is we check the result. Model fit. Did you see? It's almost the same as the previous one. Chi square acceptable. No, sorry, not chi square. The ratio acceptable. CFI acceptable. TLI almost acceptable. Nearly acceptable, but below the criteria. RMSEA acceptable, right? It's good. Yeah, it's good. Here. Huh? Here. Yeah. SRMR. It's good, right? Yeah, it's good. So generally, this model generally acceptable. Generally acceptable. So this is model fit. But we can know. We know that. Because TLI is not acceptable at the moment. Right? So I need to improve model data fit. I need to improve model fit. So how can I do that? I told you. So, okay. You go to here, modification indices. You go to modification indices to improve your model fit. Why you have modification index? It's because in here, in the output, you tick this one. You tick this one. Modification indices. You tick this one. So there are modification indices. You can see all of these are modification indices. It indicates how strongly two variables are correlated. Can you see? For example, they indicate the correlation between two variables, right? I give you an example. For example, the first one. For example, you can see this E22, E23. E22, E23. This modification in this is 29, right? It is 29. It means that these 22 and 23. Where is 22? Where is 23? This is 22, right? This is E23, right? It means these two are strongly correlated. They are strongly correlated. Okay. If two variables, two residue errors are strongly correlated, your model fit will decrease. If two residue errors are strongly correlated, the model fit will decrease. So, how to improve model fit? How to improve model fit? You draw the covariance between them. You draw the covariance between them. Then your model fit will increase. That's how we do in modification indices. Okay, now we check. Which is the largest modification index? Which is the largest modification index? Which is the largest? 39, right? No? 48. Where is it? About. 48.
Second row.
Here. Yeah. That's a problem. That's a problem. Yes, you're right. 48. This is the largest. The largest modification in this. It's the modification between E22 and the DD. This is E22, right? This is DD, right? Okay, if you need to draw covariance, you have to draw covariance between them, right? Between them. That's the first rule. You cannot draw covariance across factors. Do you understand me? No. E22. This is within this latent structure, right? DD. This is this latent structure, right? You cannot draw covariance across factors. They are different concepts. They are different structures. They are different concepts. They are different variables. It's not reasonable. It's not reasonable for you to draw covariance between different factors. That's not allowed. Okay, so we cannot do it. So which is next? This is not allowed. It's not possible. Which is next?
59.
29, right?
Yeah.
29. Huh? This is 29. 39, right? Yeah, this is the next one. 39. Okay. 39. This is between E10 and E11, right? E10, E11. Now let's check. E10, E11. Where are they? Here. This is E10. This is E11, right? Yeah. Do they fall within the same structure?
Yes.
Yes. So we can draw covariance between them. We can draw covariance between them. Now, I tell you the second rule. The first rule, just now, the first rule, again, you cannot create covariance across vectors. Now it's time for the second rule. The second rule. When you draw the covariance, you have to calculate again. You have to calculate again. Which means you cannot. It means you cannot draw all the covariances between these errors, residual errors, and then you calculate. No, when you draw one covariance, you calculate. Then you draw another covariance, then you calculate again. And the third one, and calculate. Which means when added covariance, you calculate. It's very easy to understand because when you draw a covariance, other indices will change. So when you draw the covariance between E10 and E11, you calculate. Then you go to model fit. You can see the model fit changed. The ratio decreased, right? CFI increased. Just now, the CFI is 0.901, right? Now it's 0.91. It's increased. TRI increased, right? It's increased. But it's increased, but still below the criteria. A bit below the criteria. Okay, then we go to multiplication again. Now let's find the largest. This time, the largest. Now we have 30, right? We have 30. We have maybe 30. This is the largest. Right? This is the largest. This is between 22 and 23. 22 and 23. You see, this is 22, 23, right? they in one structure, right? Yeah. So we can draw covariance between them. We can draw covariance between them. Then we calculate again. Then we check model fit again. Model fit. Did you see here? The ratio decreased further. CFI increased. More importantly, TLI now it's above the criteria. The criteria. Okay. So following this rule, we can improve your model fit. Improve model fit. But the third rule is that you cannot do this all the time. You cannot draw a lot of covariances. You draw a covariance, your degree of freedom will decrease. So you cannot draw a lot of covariances between the errors. That's not allowed. That's not. At most, you may draw. At most, you can draw 3 to 5 covariances. 3 to 5 covariances. They are very strongly correlated. That's okay. But you cannot draw many covariances between the errors. That's not okay. Okay. Now, in this way, you can improve your model fit. But we have 3 rules. I repeat the 3 rules. First, cannot draw covariance across vector structures. Across vector structures. Second, when you add one covariance, you must calculate again. The third one, you can only draw 3 to 5 covariances following this rule. Okay. Now, okay, I suggest that because later we are going to talk about structural model. We are going to talk about how to test mediation in the structural model. So we have to use another data, research motivation. Right? Research motivation. We use that data. So now, can you draw the measurement model using that data? You draw the measurement model for the data. Using this data, try to create the model on your own. You can remember this data, right? Yeah. Okay, now, our task is to create the measurement model using this data. Anything? I see that you're confused. We already created the measurement model for this data, right? Now, you're using that data create the measurement model like this. Try. So when you listen to me, you always feel it's easy. It's easy. Oh, that's easy. I can do it. When you do it on your own, you will meet many problems. Yeah. Okay. So now you do it on your own. If you cannot, you can. After class, you can try to solve these problems. Yeah. Okay. Now you do it. Complete after class. So after confirm the model fit of your measurement model, we need also know that you have to further confirm your CR values, your AVE values, and the square roots of AVE. Square roots of AVE. Square roots of AVE. Yeah. So all of these are the values that you need to further confirm the quality of your data. So next time, we are going to talk about how to calculate these values in the CIA. And after this part, we'll continue with structural model. After structural model, we'll talk about the mediation test in the structural model. That's the end of this course. That's the end of this course. And after all of these, I will tell you our term paper, which you have to submit. So these are the things that we need to finish before the end of this course. So next time we still have a lot of things to do. So pay attention. Next time we may extend our course somewhat like 20 minutes. Yeah. So maybe you have to have your lunch 20 minutes later than usual. So be patient, please. Our course before 12 o'clock. 12 o'clock. Okay, so don't forget, you have to complete the measurement model after class. Next time, next Wednesday, we are going to use this measurement model. So if you don't have that, it's hard for you to follow the procedure. Yeah? Okay? Okay, that's it.